We'll culminate this particular section by taking a look at this idea of resistance. Remember that in the last section we said that some sort of numerical summary would be resistant if it was not affected by very large or small data values that would occur within a data set. Well, we've already kind of talked about back on the idea of when we were discussing range, that the range is most certainly not resistant. Remember, because if I had a very large or small value in a data set, that's going to directly affect the range calculation. Now, what I can also then start to see is, if I think about how the rest of these values ended up being constructed, I might be able to figure out if they are resistant. Remember that the interquartile range was found by taking my data set and chopping it up into all these different little pieces so I could get my quartiles. And that required that I did some calculations like find a Q2, which was a median, and find a Q1, which was a median, and find a Q3, which was a median. And so medians are kind of inherent to the calculation of an IQR. Now, you can think back to what we did in the last section. Were medians resistant? Yes, they were. And so our IQR is definitely going to be resistant, which means it's a great value to use when I have a skewed distribution. So I'll say here, great to use with a skewed distribution. Okay, well, let's think about the idea. Let's jump here to number 4, the standard deviation. We can think about how we created or interpreted our standard deviation. We took our average, and our standard deviation was going to be used to kind of tell us how far above or below our x bar, or our average, we should jump. Well, that means that the standard deviation was tied to our x bar. And was x bar resistant back in the last section? Well, we said, no, it definitely wasn't. And so I could see then that I don't want to use this measure of spread or measure of dispersion when I'm dealing with a skewed distribution, because the mean is no longer reliable. So this is again going to be great to use, but specifically with a bell-shaped distribution. Now the variance is, remember, the exact same thing as the standard deviation, only squared, and so automatically it will not be resistant because the standard deviation was not resistant. So what we see here is, again, that there's going to be this kind of connection between IQR, the idea of medians, and skewed distributions. Just like when we talk about standard deviation, there's a tie to averages and bell-shaped distributions. They kind of come in the standard triplet form. And so these triplets are very important for us to remember. Values like the range and the variance are not going to be used very often, but the interquartile range, median, and skewed, that's going to be used as a triplet all the time. Standard deviation, averages, bell-shaped distributions, used all the time. So take a look down here at example number 3, and you can see how I'm going to use this. What measure of center, what measure of dispersion should be used to most accurately reflect each of the following data sets? So remember, measures of center were like mean, median, and mode. Measures of dispersion were range, IQR, variance, standard deviation. Well, notice again that since I have these triplets formed, I can immediately start to kind of deduce the following. First here, I'll focus on the shape of my distribution. Notice that this shape is very easily seen as skewed to the right. Well, if I have again a nice skewed distribution, I can easily see that my measure of center, I should probably just go ahead and use the median, because again, that always went with the skewed distributions. What measure of dispersion should I use? IQR, all the time with no exceptions there, because again, I have a skewed distribution. So I'll say here, measure of spread or measure of dispersion can easily be my IQR. So notice that once I establish skewed, I kind of automatically have to write in these other values. I don't have a choice on those. Similarly over here, when I talk about the shape of this distribution, I can see this is pretty bell-shaped. And so once I establish that I have a bell-shaped distribution, I automatically know what measure of spread and what measure of center I want to use. The measure of center here should definitely be the mean, because whenever I have bell-shaped, I choose the mean. And when I talk about a measure of spread, I know that I should automatically choose my standard deviation, or what I'll often abbreviate as STD-dev. You're free to use that interpretation or shorthand in your work as well. So this is a really important point to kind of culminate this section, that I'm always going to be using things in these kind of red group triplets and these blue group triplets all the time. So the moment I know that I'm using one of these three things, I know kind of immediately what the other two should be. So if I said, hey, I'm using the standard deviation to interpret or the spread of a data set, what other things can you probably tell me about this data set? Well, you could say, like, I know the measure of center I should use should be the mean, and I know it's probably bell-shaped. Right? And same thing when I go to the red group. So this kind of helps to tie together those three different ways of measuring a data set that we've seen throughout the last two sections. In the sections to come, we'll zoom in a little bit more on this meaning of the standard deviation and start to see how we can use it in a bit more detail.